Okay, starting with 53. The directions for this question are on the previous page, so let me flip back and read them. Use the information provided to write the standard form equation of each ellipse. So this is an ellipse with a major axis that's vertical, a center of -3/8. The major axis is 30 units long. The minor axis is 10 units long. Okay, if the major axis is vertical, what will the ellipse look like? Right, it'll look something like this. Okay? Now, the center is -3/8. And remember, the center is your H and your K. In the formula, where does H go? With the X or the Y? Correct. So, that rules out which answer choice? A. They have them flip-flop. They have the 8 with the X, and the 8 should be with the Y. Okay, so now, another thing that could have helped you eliminate A and C right away is just by reading the first sentence. The major axis is vertical. Vertical is which axis? The y-axis. So, when we look at all of these equations, if the y-axis is the major axis, shouldn't the larger of the two denominators be under the y? Well, with C, under the y is the smaller value, so C is automatically out just by reading that the major axis is vertical. Okay, now, if the major axis, which we've already talked about, is y, is 30 units long. So this length is 30. What is the length from the center to the side? 15. If the minor axis is 10 units long, what is the length from the center to the side? 5. What do you do with those values when you put them in the equation? Square them. So 5 squared will become 25, and that's horizontal, so x. So 25 should be under x. 15 squared is 225, and that's vertical, so that number should be under the y. So it's D. Right, the only way you would have ended up with a 1 under the x is if this had only been 1 unit, and that meant the total would have been 2, and they told us it was 10. Okay? Alright, number 55. Condense each expression to a single logarithm. What does single mean? 1. So when you're writing it as a single logarithm, you're only going to write the word log one time, which makes sense. Look at all the answers. They write log one time. The base for both of those is base 2. Now, if it was plus addition in expanded form, what is it in condensed form? Multiplication. Remember, addition changes to multiplication. Subtraction would have changed to division. Now, before you even knew that, there were some of these choices that by common sense we could have marked off. Not necessarily A, not quite. I mean, you have to have a teeny bit of knowledge to mark off A. But by common sense, is there a 4 anywhere up there? No. Is there a W anywhere up there? No. Now, some of you may have noticed that with A, it's division, and this was addition. So, but that's not common sense. That's something you learn. That addition goes with multiplication. Subtraction would have gone with division. But another thing that stands out about A to show us it's wrong is with the U variable, what number's out front? 5. That says U to the 20th power. Remember, the number out in the front is the power. So like U should be raised to the 5th power. B should be raised to the 20th power, and they should be multiplied, because whenever you write it as a single log, you multiply if it were addition beforehand. Does that make sense? Okay, number 57. Identify the domain, and that shouldn't say range, it should say asymptote. Okay, identify the domain and the asymptote of each. Well, when you hear the word domain, you should think of what? X. X-axis. Okay, so what would help us here? To graph it, we need a visual. So let's graph it. Y equals, now we probably need to review how to type something like this in. Does anybody remember how to get to log base? Okay, it is all the way down the list. So a shortcut is alpha A, because down at the bottom it's beside the letter A. If you don't remember that, you can just hit math and go all the way down, or you can just hit up to get to it faster. Another way you can get to it is by hitting alpha window, and there it is right there. Now earlier today, one of my students found something else that could be helpful for a lot of things. If you hit second and then 0, what's above 0? Catalog. Then, whatever you're trying to find, you just type in the first letter. Like we were trying to find log base. So here's L, hit L. And then there's all of the words that start with L. And then you would just go down until you found log base. I'm not sure. Where is it? Okay, so let's graph it. Log base 5 of x plus 4 minus 3. Now before we actually graph it, can you tell me what shifts it's going to do? Left 4, down 3. Remember, inside numbers shift it left and right, and it's opposite of what you would think it would do. Plus 4 is actually left, minus 4 is actually right. Outside numbers move it up and down, plus is up, minus is down. Okay, now when we graph it, we already said the domain deals with the x-axis, which runs left to right. How far does this function travel to the left? -4. How far does it travel to the right? Infinity. So -4 to infinity. That's the only choice with -4 to infinity. But can't you see that it comes in and makes a sharp turn right there at -4? That's because there's an asymptote. What kind of asymptote is it? Vertical, though, right? And vertical asymptotes cross the x-axis. That's why it says x equals -4. So if you remember that logarithms have vertical asymptotes, you can mark out A and D right away because they both say y equals, and y equals is a horizontal asymptote. Does that make sense? Or once you look at the picture, I can kind of see this is a vertical asymptote. So it should start with x equals, not y equals. Okay, moving on, 59. You put $1,000 into an investment yielding 6% annual interest. How much money do you have at the end of those 2 years? Okay, well the formula for this is A equals the principal amount times 1 plus or minus R raised to the t power. Okay, R stands for rate, T stands for time. 1 represents 100%, because don't you always have 100% of what you started with, and then plus or minus whatever you're gaining or losing? Okay, so A equals what goes in the P? Right, that's what you started with. Now, we're writing 1, and that 1 represents 100% of the 1,000. Is this plus or minus? Because it's an investment that's yielding annual interest, so you're gaining money. And how do you write 6%? 0.06. And then what is the t value? 2. Now type that in and see what you get. This is your principal amount, your starting value. 1 plus your rate, 6% rate, raised to 2 years. Yeah. Okay, and that should be $1,123.60. Now, I don't know if it'll be this easy on the actual test with the scores. Like I made this up and I didn't pay a lot of attention to the choices. Honestly, I just wanted to make sure there was a right one. But if you start out with $1,000 and you're making money, after 2 years, aren't you going to have more than $1,000? Well, look at A, C, and D. None of those are more than $1,000. So even if you hadn't remembered the formula, common sense tells you B has to be it. No, you don't get any formula. It's not my choice. It's not my choice.
Whose choice is it?
I guess the county. All right, number 61. Solve each equation. Okay, how would you do this problem? Well, you're trying to solve for x. Anytime you're trying to solve for x and you have multiple choice, what can you do? You can just plug in each one until you get to the one that equals 2, right? Okay, so we need to do log base. So any way you can pull up log base is fine. Okay, now we're trying to figure out what x is. Well, A says it's 9, so let's plug in 9 for the base. Of 25 25. Does that equal 2? No, so A is not it. So now let's try B, 2. So math, alpha, math. There's 2, or this time we're trying 2 in for x. So 2 of 25. That does not equal 2. So now we're trying 25. Math, alpha, math. Log base 25 of 25. Oops. 1. That's not what we're looking for. So obviously it's D. If you have time, you better check it just to make sure. But do you see how long it can take sometimes when you have to plug every answer in? Okay? Right. Because look, this is in logarithmic form. Remember back when I taught you how to change it to exponential form? The base always stays where it is. These two just flip-flop. The 2 comes over here as the exponent. The 25 goes over there. And then you can see blank squared equals 25. Well, 5 squared equals 25. Okay? All right, number 63. I'm going to work this one out the right way, but honestly, you're probably going to end up just plugging in each choice on the test. But I want to show you, because some of you might remember how to do it. The first thing that I've got to do is condense it. So they're both log base 4, so I'm going to write that once. Since it's subtraction, when I condense it, it will be division. Well, what is the numerator? X plus 11. What's the denominator? X plus 2, and then equals log 10. Well, there's no reason to keep writing log 10 when we could just evaluate that with the calculator. Okay, notice that there's no visible base. That means it's a base 10. So yeah, you could do math, alpha, math, and type in log base 10 of 10. But that's kind of a waste of time because there's a special button right here on the calculator to type in when it's base 10. Just log 10 and you still get the same answer. So it's 1. Okay, now just like in the last problem, we're going to rearrange it into exponential form. So 4 stays. The 1 comes over here as the exponent, and then those both go, that fraction goes over here. What is 4 to the first power? 4. So we'll just kind of ignore that 1. Now, how do we start solving? At this point, if you even make it that far, couldn't you just plug in the numbers here and here until you found the one that made a 4? But the real way to do it is multiply by x plus 2 to cancel that out. Multiply this side by x plus 2. What does this side now become? 4x plus 8. And then the right side, all that's left is the x plus 11. Now we just have a multi-step equation. So subtract the 8, subtract the 8, that becomes a 3. Subtract the x, that becomes a 3x. And then divide by 3. Divide by 3, so x equals 1. 3 divided by 3 is 1. Now, I know that's a tougher one. That's a lot to remember how to do. You have to condense, then you have to rewrite into exponential, and then you have to use a lot of algebra. So remember, you do have the choice of just typing in each number until you find the one that equals log 10, which is 1. Okay? All right, 65. We have the cube root of 6n all squared. Any ideas how to do this? Right. We have to rewrite the cube root with an exponent. How do you rewrite the cube root as an exponent? 6n to the 1/3, right. But then you got to remember that that's squared. And what do you do when you have a power to a power? Multiply. So what's 1/3 times 2? 2/3. So it is C. Okay? Now, a lot of you have just learned to just go straight from here to here, and that's fine. Okay? Well, and there's some common sense here. 5, really? And 4n. And then 3/4. I don't see a 4 anywhere up there. And this one doesn't have a 6, so, I mean, you can really use a lot of common sense on this test. Okay, 67. We have 381 equals 6 plus 3a raised to the 3 over 2. Obviously, we're trying to solve for a. So, yes, you could just plug in each of the 4 choices in a until you found the one that equaled 381. Or you could solve using algebra. How would we start that process? Right? Okay, what is 381 minus 6? Right? Now that equals 3a raised to the 3 halves. What do you do now? Divide by 3. So now we have something equals a to the 3 halves. 125. Now, how do you now isolate the a? How do you get this exponent of 3 halves to go away? Okay, look, we want it to equal 1 so that it'll cancel, right? Isn't that the goal? If you make something 1, it's like canceling it out because you don't have to write a 1. 3 halves times what is 1? 2/3. The reciprocal of anything will equal 1. Like 4 over 3 times 3 over 4 equals 1. So anytime you're trying to cancel out a number, just multiply it by its reciprocal. Well, to multiply this by its reciprocal, don't you have to raise it to the reciprocal? Because the power times the power is when you multiply. So if we raise this one to the 2/3, it will cancel it out for us, leaving a by itself. But what does that mean? The other one has to be raised to the 2/3. And what is 125 to the 2/3? 25. So D. Now remember, you do have the choice of just plugging them in. 6 plus 3 times a, which we know is 25, so I'll just plug in that one, raised to the 3 halves. See how all I've done is I've plugged in the right side? And if 25 is the right answer, what should I get when I hit enter? 381, and I did. Okay, there's no reason to miss that kind of question on a test. No, there's no unless. Unless you don't have a calculator, which is not the case. Okay, number 69. Identify. The directions are wrong here. That shouldn't have been there. It should have still stayed under this section. Solve each equation. Why don't y'all take a minute and try that one by yourself? Go. 69. The first. Now remember, I'm going to go over it the right way, but there is always the option of plugging in each one until you find the one that equals 81. The first thing I would have done is I'd have changed this x and raised it to the 1/3 power. Then that's raised to the 4th power, so that becomes x to the 4/3. Now we learned a few minutes ago, how do you get rid of that 4/3? Raise it to its reciprocal, because when you raise a power to another power, you multiply them and they'll cancel out. That means we have to raise this one to the 3/4 and you get 27. Okay? 71. Identify the x-intercept of each radical function. What is an x-intercept? It was B. Where it crosses the x-axis. So what would be helpful here? To graph it. Y equals -4 plus 2 square root of x. Okay, but before we graph it, to be an x-intercept, it has to be on the x-axis, which means it didn't go up or down. So the y value of any x-intercept has to be 0. The only point up there with a y value of 0 is A. And yes, it's 4, 0. Just remember, guys, x-intercepts always have a 0 as their y-coordinate. Otherwise, they wouldn't be sitting on the x-axis. What is C called? C would be a y-intercept because you didn't move left or right, you just moved up 4. Okay, 73. Find the interquartile range for each data set. How do you find IQR? Okay, that is one way of doing it. Okay, but do y'all know how to read the stem and leaf plot? Okay, like they give you a little key, 2 and then the bar 9 equals 29. So what's this 1 and then the bar 9? 19. So what's your next number?
20.
What's your next number? 31, 31, 31. 33. You don't multiply them. 33, 34. Shh, guys, stay quiet, please. 36, 37, 46, 46. Now, like Jordan said, you can put these in a list in the calculator. It'll give you the Q3 and Q1, and you just do Q3 minus Q1. Or if you do it by hand, you first have to find Q2, which is 31. That's the middle number of all the data. There's 8 on this side of it and 8 on this side of it. So that's your Q2. How do you find your Q1? The middle of the lower half. What's the middle number of the lower half? You sure about that? Two numbers split the middle. No. 26.5. You go to stat, edit. Okay, what is the middle number of the upper half? 35 and 36, which averages to? Okay. So your Q3 is 35.5. Your Q1 is 26.5. So when you subtract those, you get 9. Or, like I said, you can do stat, edit, put them all in the list, then stat, calc, one variable. It'll pull it up. You'll have your Q3 and Q1. You just have to remember to subtract them. Okay, 75. We're not done. The scores on Miss Burke's last math test were normally distributed with a mean of 70 and a standard deviation of 5 points. So what you need to do is, normal distribution means the data is in the shape of a bell. Okay, so the middle of the curve is always the mean, which in this case is 70. Then you have people that could score 1 standard deviation above, 2 above, or even 3 above. But on the other side, you have people that could score 1 standard deviation below it, 2 below it, or 3 below it. How do we get those values? Right, if the standard deviation is 5 points, to the right we add 5 for each standard deviation, and to the left we subtract 5. Now, what are the percentages of the curve? It can be helpful to remember that the empirical rule is also known as the 68, which is 34 plus 34, 95, which is what these 4 sections will add up to, 99.7, which is what these 6 sections will add up to. Does anybody remember these 2 sections? Right. And then 2.35, 2.35, and then 1.5 or 0.15, 0.15. All of them should add up to 100. Okay, so where is 68% of the scores? What range? 65 to 75. Those add up to 68. Okay, given approximately normal distribution with a mean of 121 and a standard deviation of 40, answer the following questions. So isn't this the same exact kind of thing? So couldn't we use this bell curve again just with the new mean and the new deviation? So what will the middle number be this time? What will this number be? What will this be? And then what will this be? Okay, so 2.35% of the values are within what range? Right. This would be it, right? 1 to 41, but that's not one of the choices. So the other 2.35% range is 201 to 241. Okay, 79, last question. Label each dot plot as normal distribution, skewed left, skewed right, or can't be determined.
Skewed right.
Skewed right. It has a tail to the right. Okay, let me quickly show you one more thing. If you go to my blog, which is on the front of every packet, jmath.wordpress.com, each day I have been posting the video of me going over it, and look, I've posted a blank copy of the review sheet.
Rod.
The best way to study is print it off. If you don't have a printer, it's okay. Just leave it up on the screen, work it on notebook paper. Take it like it's a practice test, only the odds. We'll save the evens for the in-class practice test. And then can't you check your answers by what we've been doing in here? The ones you get wrong, how could you relearn them this weekend? The videos.